Hi there, I'm Brian Issa. A warm Namibian welcome to all advanced subsidiary level mathematics learners and everybody else interested in learning maths. We appreciate your company and we hope that you are going to enjoy the lesson. Many learners struggle with differentiation, but this video will walk you through exactly what you need to know so you can master it. Our lesson objectives are to help you know what differentiation is, how to apply the rules of differentiation of functions, and of course to apply differentiation to simple functions. Let's get started. Firstly, differentiation means finding the rate of change of one quantity with respect to another. The same can be explained as the rate of change of a function f of x with respect to x. This can be found by finding the derived function f prime x. Take a moment to memorize the notations on the screen. When doing differentiation, we use the notations f prime x, f double prime x, or the second derivative of x, dy dx, and d squared y dx squared. Once you have got this, learning outcome 1 can be ticked off the list. You have got this. Next, we have to discuss the rules of differentiation. First, the constant rule. The constant rule states that the derivative of any constant or number is 0. This means that, for example, if y is equals to 3, then dy dx is 0. This means that a y value on its own will not change if you change x. The rate of change is 0. Got it? Next is the power rule. This rule states that if y is equals to x to the power of n, then dy dx is equals to n times x to the power of n minus 1 for any integer n. We will discuss more rules as we continue with the lesson. For now, since you already know two rules of differentiation, let's do an example. Differentiate y is equals to x to the power of 5. So let's use the power rule and find the derivative function of y is equals to x to the power 5. Remember, there is a 1 in front of x power 5. So y is equals to 1 times x to the power 5. Multiply the exponent 5 by the coefficient 1 to get 5. Now decrease the exponent by 1 to get 4. If you look at the power rule, you will see that there is an n at the front and n minus 1 is the new exponent. From y is equals to x to the power 5, apply the power law to get dy dx is equals to 5 times x to the power of 5 minus 1, which is equals to 5x to the power of 4. Another example, stay with me. Example 2. Find the derivative of f of x is equals to 4x cubed. If the coefficient is not 1, then let k be a real number and n an integer. To apply the power rule, first multiply n by k. This gives us dy dx is equals to 3 times 4 equals to 12. Then subtract 1 from 3 to get 2. Dy dx is also called the first derivative, written as f prime of x. So dy dx, the first derivative, is equals to 12x squared. Please practice a few of these in your notebook until you feel confident using the power and constant rules. Viewers, we want to also show you how to apply the sum and difference rule. Then after that, we do a combination of that and we are done. The sum rule. If y is equals to f of x plus g of x, we can find dy dx by differentiating the two functions separately and then adding the terms. But for y is equals to f of x minus g of x, we find dy dx by differentiating the two functions separately and finding their difference. Here is example 3. f of x is equals to 3x squared plus 2x. Find f prime x. And f of x is equals to x cubed minus 5x squared. I will work out the solution with you. First, we apply the power rule to each term. Multiply the integer by the function. Subtract 1 from the exponent. And then we get f of x is equals to 3x squared plus 2x. F prime x is equals to 3 times 2 x to the power of 2 minus 1 plus 2 times 1 x to the power of 1 minus 1. F prime x is equals to 6x to the power of 2 minus 1 plus 2 times x to the power of 1 minus 1. And we get 6x plus 2. The second one is just as easy. Number 2. F of x is equals to x cubed minus 5x squared. Multiply the integer by the function and subtract 1 from the exponent. F prime x is equals to 3 times x to the power of 3 minus 1 minus 5 times 2 x to the power of 2 minus 1. F prime x is equals to 3 x to the power of 3 minus 1 minus 10 x to the power of 2 minus 1. Then we get equals to 3x squared minus 10x. You've got this right? Well done. Let's do a mixture of the three rules we have learned so far. In example 4, there are 3 short problems. I will go through the solutions with you. Number 1. Y is equals to x to the power of 10. Find y prime. Then solutions. Y is equals to x to the power of 10. Now you know you must simply multiply the number before the x, which is 1, by 10 and deduct 1 from the exponent 10. Y prime is equals to 10 x to the power of 10 minus 1. So you get y prime is equals to 10 x to the power of 10 minus 1. And your final answer is equals to 10 x to the power of 9. The second problem, find the derivative of y is equals to 6x squared. Multiply the coefficient, which is 6, by the integer 2, and then deduct 1 from the exponent 2. You get y prime is equals to 6 times 2 x to the power of 2 minus 1. And we get equals to 12 x to the power of 1, which is just equals to 12x. Last one. It's a bit longer, but the process is the same. Differentiate f of x is equals to negative 3x cubed plus 5x squared minus 2x minus 3. F prime of x is equals to negative 3 times 3 x to the power of 3 minus 1 plus 5 times 2 x to the power of 2 minus 1 minus 2 times 1 x to the power of 1 minus 1 minus 0. Remember that the constant rule states that the derivative of any constant is 0. So the last term is 0. Simplifying gives equals to negative 9x squared plus 10 x to the power of 1 minus 2 x to the power of 0 minus 0. You still remember that anything with exponent 0 is 1, right? Meaning equals to negative 9x squared plus 10x minus 2 times 1 minus 0 equals to negative 9x squared plus 10x minus 2. Viewers, thank you for watching our lesson today. I hope it has made you feel more confident about the basics of differentiation. Meanwhile, before we say goodbye, let's have a summary of what we have learned today. We have seen in today's lesson that when doing differentiation, we use the notations f prime x, f double prime x, dy dx, and d squared y dx squared. The constant rule states that the derivative of any constant is 0. The power rule states that if y is equals to x to the power of n, then dy dx is equals to n x to the power of n minus 1 for any positive integer n. The constant times a function rule states that if y is equals to k x to the power of n, then dy dx is equals to k times n x to the power of n minus 1. The sum and difference rules states if y is equals to f of x plus g of x, we find dy dx by differentiating the two functions separately and taking their sum. If y is equal to f of x minus g of x, we find dy dx by differentiating the two functions separately and taking their difference. Please do these and more examples on your own. They will help you in your exams too. See you soon. Bye.